Hi, can everyone hear me? Okay, then I'm not going to use the microphone because I have very bad, I don't like using microphones. Yeah. Okay, let me just, okay, never mind. Okay, so first, actually I wanted to thank the Women Who Code organizing team because so far this has been a fantastic conference. It's been very well organized. So I think we should give a round of applause just to all of our volunteers here. 1, 2, 3. I'm sure there are more of you who are not wearing shirts. But yeah, I just wanted to thank all of you for organizing a really great conference. Yeah. So my topic is best practices for creating reproducible analytics within teams using R. So first, a little about me. You can read the slides, but basically what it says is that I'm from UOB's Group Compliance AAA team. So mainly my focus is on anti-money laundering and countering of terrorism financing. So we're capturing people who are trying to launder money, like in 1MDB for my friendly Malaysians. And people who are trying to avoid sanctions, like people who are trying to deal with North Korea, things like that. Yeah, so I'm actually not from the IT department. Yeah, and prior to that, I was in healthcare, community care, and I was also, prior to that, I was in a boutique software house. And another important thing, which I think is important to know, because this is Women Who Code, is I'm a mother of 2 young kids. So it's important to know that as well as being a woman who code, you can be a mother and you can code. And you can set an example for your kids as well. So that's also one of the reasons I'm here today, because I want that people know that you can be a mother as well. Okay, so this is my basic agenda. It is also, I think it's on the website as well. Okay, so first slide, what is R? This is taken directly from the R Foundation website about what is R. So basically, R is a programming language which is based upon S. So there are too many alphabets. Yeah, you have R, you have C, you have C#, C++. They're just not very creative, right? Yeah. So R is widely used for analytics and statisticians for visualizing data. So these are some of the high-profile companies using R. So I have some links below with the references, so you can check that out later. But mainly, I wanted to show you why people like to do visualization and statistics using R. So this is actually done by the BBC. So these are the kind of graphics which they produce using R. So you can produce really professional looking graphics using R. Especially like when you have people like the BBC who come and create their own library and themes, and you can just apply it very easily. So this is the main reason why I encourage people to use analytics using R. You cannot create a game, arcade game using R. You could have gone to my colleague. Could have gone to the earlier session run by Yuling. She does it using Python. But for analytics, R is really, really good. So usually when people use R, they use it in conjunction with RStudio. So what is RStudio? RStudio is the IDE for R. So basically it's like your Visual Studio for C++. It's your graphical user interface for dealing with R. If you don't want to use RStudio, you can use your favorite Notepad, Notepad++, VI, anything you want if you don't want to use RStudio. You can download it here. It runs on Windows, Mac, Linux, and it has a server version as well. Okay, So what is R Markdown? So most people have heard of R. Well, actually not. A lot of people haven't heard of R. Most people have heard of Python. But not so many people have heard of R Markdown. So actually my slides are done on R Markdown. They're not done on PowerPoint. Maybe you saw just then they were in a HTML. So they're actually done in R Markdown. And it's actually very easy for you to just knit the document, and then you can come up with some sort of HTML document. Knit your code, and you can come up with some sort of HTML document or slides. So let me just give you an example of how you would do that. So this is my R Markdown. And how would you create an R Markdown? So you go to New File, you create New R Markdown, and then you put in your title, test. Then you can choose to generate the HTML, PDF, Word. If you want to generate it to PDF or Word, then please make sure you have like the relevant PDF, Word executable installed. I don't, so I'm not going to use it. And you could also generate to presentation, or Shiny is actually interactive dashboard. So I won't go into that because that's a bit more complicated. So I'll just generate a document using R. Yeah. So you can see this is a basic document. This is an R Markdown is taken, that is where I took my slides. And if you click knit, I can save it. You can see it knitting, and then ta-da, it comes up. Yeah, very little work involved, right? So one thing is about the R Markdown is that you can see the first things which are set up: your title, your author, your date, your output. So for my case, if you don't want it to be an HTML document, you can use the slides. So what I did was a slides presentation, right? So I just copy it, and I can knit to slides. So if you didn't want to do it like what I did just then and select it, then you could just knit it to slides. So that's the top part. That's what we call the YAML header. So you put all of your environment variables there. Then after that, you have the setup chunk. So the setup chunk, yeah, so you just take what they give you, just do that. And then include equals false means that it's run, but you don't see it on the slide. So you remember, yeah, I just removed it. But you remember my sample? You didn't see this here anywhere. Yeah, because I just put include equals false because it's not there. Then after that, you saw in the sample, they had the summary of the class. So this is basically saying I want to run this code in R, and then I will call this code cars. So then it calls this function called summary, and then it runs it on the cars dataset, which is preloaded in R. And then after that, you can see the sample here that you can also embed plots, for example. So if you go to the next slide, you can see it's exactly what it says, right? And if you notice, right, this last slide, it doesn't have your plot pressure. It doesn't have your code in it, right? Because we put echo equals false. So if you notice, actually at the top, it says echo equals true. So echo equals true means generally I want to show my code throughout the slides, throughout the whole document. But if further down you decide for specific sections you decide I don't want to see it, then you can just put echo equals false. Yeah. Then in that case you would just see the plot without the code. Yeah. So this is useful because sometimes I'm not sharing it with my teammates. I'm sharing it with my boss. I'm sharing it with people who want to make decisions, and they don't want to see my code. They just want to see the graph and what it is. So I would just say, this is a plot of A, B, C, D, E over the period January to December 2019, and this is my results. So I don't need to actually put in the code. I don't need to display, I can choose whether or not to display the code, but if somebody wants to check my work later, it's easy for me to generate it with or without the code. So that's why it's important in terms of reproducibility, because a lot of the times, like, let's say a lot of the times, if I need to reproduce stuff in Excel, for example, I cannot go and check every single cell in the Excel file. It's much too painful for me to do that. Yeah. Okay, so that's a crash course on how you use R Markdown. Okay, so the first slide, if you are very lucky, you will already have it in a database somewhere. Then you can load it from ODBC. If you are taking it from CSV or Excel, you can actually load the data in too. Strongly recommend that your data source or even your ODBC connection, if you're using ODBC, it be parameterized. So what do I mean by that? If you look at my code, I actually have like a params and data source. So if I call params the data source, the parameters the data source, you can see it's here, right? And this is good because sometimes I need to give this R Markdown file to other departments to use. And they don't want to, and it's difficult for them to look through my code to find out where to put the folder. And the folder is always going to be different no matter who runs it, right? So they can just key in the folder. They know where to put the parameter. So I strongly recommend the parameter be put here. Things like that, they should also be put there. Okay. And just so that you know, for this exercise, actually, I'm using data from data.gov. So if you have a copy of my slides, then you can actually follow the reproducibility in the same steps, which I'm showing up here. Yeah. So you can see that for this, I've actually just read the CSV based on the parameter. Then after that, I call some libraries. So if you're not familiar with R and this is the first time you're installing RStudio, then before you run this, you do need to install the libraries. So to install the libraries, you can either go to Tools, Install, and then you can just type it in. Or you can, if you're comfortable with the command line, you can just install .packages. Dplyr, for example. So this is just like if you haven't used it before and it's the first time you're running it, you'll need to install it for the first time. Okay, so these are the libraries which I'm using for this demo. We have Dplyr, mainly used for like reshaping summarization. Ggplot 2, so that's for graphical visualization. So that's what we saw on the BBC website just then. We have ggthemes, which you also needed to do prettier graphics, like what we saw on the BBC site. Extra fonts, if you want to use something other than Arial. And maps, because one of the last slides will be showing maps. Okay, so the first thing you should do when your data comes in is that you should check that it is what you think it is. Because, I don't know, so far I have never been lucky enough to always be what it says it is. So you show that how many rows, the dimensions show you how many rows and how many columns of data. So you can check with your source team, like, are you really expecting 7,722 rows of data? Okay. Then after that, you can look at the structure of the data frame. So you can see here from this structure is that my data frame has 5 variables. So it looks like columns, 5 columns. They're called month, level 1, 2, 3, and value. They're also stored as factors, which usually confuses people who are using R for the first time, because you usually don't deal with factors outside once you've left university. Generally, that's the case. Okay. So first, you have to transform the data structure when you come across this kind of thing. So strings as factors equals true is our default behavior, but you can override it. So there are two ways to do this. So if you've already loaded the data, you can just change it as a data frame, then just change it to string as factors equals false. Otherwise, when you actually load the data, you can just set it as false as well. So here you can see now they become a character. So what's the difference between this one, this slide, and this slide? From the factors, I can see that I have 3 levels at level 2. So I had 1 level at level 1. So that means I actually only have one type of observation in this column. I have 3 types of observations in this column. So if you're just doing like statistical analysis, that's probably good enough. You don't actually need to convert it to text. But if you are going to do amending the text and things like that, then it's good to convert it to a string. Yeah. So like as factors, you can see it provides useful information. Like I have 11 types of level 3, which looks like countries. And then my factors, I have 6,133 levels of value, which actually means I have that many different types of numbers in my value, or different types of variables in my value. So you can see not all of them are numbers. Like the first one is hyphen, right? Yeah. So yeah, when you put it as string as factors, then it becomes all characters. Okay. So then you probably also notice, like based on the last slide, that the values look like numbers. So what do we do? So you usually want to handle, you convert it to numbers, right? So firstly, you need to figure out how you want to handle the not available stuff, right? And so what I would usually do is that I would check what becomes not available when I convert it to a numeric. So I get the index. So that's the formula to get the index. Then based on the index, then I will actually check what are the values here what would be converted to NA. Yeah. So here is hyphen and NA. So you do need to like go back to your source and check whether these are really like NA values, or you should handle it as 0 or 99999 or whatever, right? So, but for this particular exercise, we will just convert it to numeric. We'll just say it's good to go. So I convert it to numeric, and you note you still have the warning message that the NA is introduced by coercion. But that's okay, because we already did the checking the last time round. And then I check the structure again. So now it's actually a numeric, right? Okay. So other than the numeric, probably you noticed that the month column looks like a date, right? So I want to convert it to a date format. Why do you want to do this? Consistency of calculations, plotting of monthly, yearly totals. Generally, it just makes sense to convert it to a date because that is what it is. Generally, like you can't call a date year, you can't call a date 2018 February without any day. So what I have done here is that I've just added like 01 as the day. So it adds 01 as the day. So you have the arrivals $month, and then you have the separator, and then you have 01. So every value in this column has added a 01 to it, a hyphen 01 to it. Then after that, I change it to date format. So this is the format which I have used. So because I wanted its year is 4 years, month, day, right? And then after that, I can check the format to see it's what I expect. Labeling data. If you're going to share your stuff with other people, please relabel the column names, because when other people look at it, generally they're not going to remember what is level 2 and level 3. Yeah. So for this case, I change level 2 to region, level 3 to country. You look at the data and you choose what makes the most sense. And then after that, I check the names to see that now they make sense. I didn't change level 1 because I'm going to show you how to remove it later. So the Ggplot library. So this is a very popular R library with data scientists. So I use the Ggplot library to select the columns which I want to use. So you can see in my code snippet that you can actually write it in base R. So like this is actually a thing in base R. But I personally feel it's more readable if you, even for non-technical people, if you write it this way. So like people know that the first parameter is the data frame, and then the subsequent parameters are the columns you want to select. Yeah. Then after that, you check that like the columns you want or the variables you want remain. Okay. So for this exercise, I actually put that we want to look at the most recent 12 months of data in the data set. So if you could recall from my many slides ago, it's actually the Changi Airport arrival data taken from data.gov.sg. So if you downloaded it today, maybe the latest data is not 2019 June, maybe it's July, or it won't be August because that's today's date. But let's say if you do it in like a few months' time or a year down the road, the most recent 12 months will be different. Yeah, that's basically one thing. So in order to find the most recent 12 months of data, first you find the most recent month. Then after that, you can use the sequence. You can use sequence to get the sequence. Yeah, so it says by the length is actually specifying I only want 2 values in my sequence. Minus 12 months means I want it to be decreasing. So you remember the maximum month was June 2019. So if I decrease it by 12 months, it becomes 2018 June. Okay, so then we only take the second value of that sequence, and then we set it as the lower bound. So you can see it's still the right value. And then after that, I filter it based on I only want to see that data which is greater than the month lower bound. So I think you can see that it's kind of like it's really step by step, and then it's really easy for people to follow. So that's generally why I encourage people to do analytics this way, because it's important that people can follow your work, and you might have forgotten how you did it like 12 months ago or a few years ago. Okay. Then you can use the count function to verify if your filtering is successful. So you can see there are only 12. It's a table, 12 by 12, 12 by 2. So there's only 12 rows. So that means it's successful. I only have 12 months of data. And actually what it's doing is it's counting there's like, for every month, I have 11 rows of data. Yeah. So if, let's say you have like a time series, like what my fellow speaker VB was saying in his earlier speech, his earlier talk, like his set of data is like one transaction is one row. But for this case, it's already summarized, so that's why you have only have 11 for every single month. Okay. Usually this is not what you want to see. Yeah, you don't need to know that. So what I will do is that actually I will group it by month, and then I will see the format. So you can see that I use the group by function, and I use the summarize function. Okay? Sorry, this is something wrong in the slide. Typo in the slide. I just used the group by function. So actually, I just used the group by function, and then it summed up everything here. Yeah. Okay. So the slide is makes more sense. So first, I group the data by the variable. So in this case, I group by country. Then I summarize the value. Then I arrange it by descending. Because usually, the most popular thing people ask me, I want to see the top 5 this X, X, Y, Y this month. I want to see the bottom X, X, Y, Y this month. So it's important that you know how to generate top 5, top 10, bottom 5. If you want to generate bottom 5, bottom 10, just remove the descending. And then you'll get the bottom one. And like 5, if you want the top 10, then you just change the 5 to 10. Okay. So other than producing tables, usually people want to see plots. Like most people prefer visual representation as opposed to like text. So generally, I suggest that before you run all your ggplots, you set the theme so that it's standardized. For this case, I've used the Women Who Code theme. So I've set like some fonts, font colors. It's like this is the Women Who Code color, the green. And I set some of the text, families, and things like that. So this is, if you're familiar with HTML or CSS, this should be familiar to you. Yeah. Yeah. So most people like have some problem understanding ggplot at first. So generally, this is how it works. First, you have the data set. Then you set the aesthetics. Then you decide the layer of the type of graph you want to use. And then of course you can put in like labels, X label, Y labels, things like that. So this is my example here. So I'm doing a bar chart. And actually you notice what I've done is that I've used the stat equals, I set the Y is equal to the value. So, and I've actually used stat equals identity. So why do I do this? Because by default, actually, R uses frequency, so they expect actually something like a time series, whereas this is already summarized data. So I have another slide later on which will give you an example. What happens if we don't do this? So after that, we do the plot, we apply the theme, and then it looks like this. So it looks pretty nice, right? So you have your month, you have your number of passengers, you have your year months, just like what I said in the, and it's all according to the theme, which was okay. So like I said, I was going to explain to you about the stat equals identity. So yeah, so the default value of Y is the frequency. So if you remove stat equals identity and you remove the Y, then it will actually look like this. So this is a very nice stripy type of graph. If you remember a few slides ago, it's like every month has 11 rows. So basically, I think that means like probably every month has yeah. So you can see that says it goes up to 11, right? So you have one row. Everything is one row. So if you have a time series or something like that, it would make sense to use this, but not for the exercise which we're doing. Okay, so I'm just going to go through the Ggplot grammar again, because yeah, that's what the content of my slide is. And but we will use a line chart this time. So once again, we have the data. The data is the arrivals data frame. Your X value is the year, month, the date. Your Y is the value. You group it by country because you want the lines by country. We sum up the values, otherwise you will get 11 for everything. And then you set it as a line chart. So this is what it looks like. So the next one is actually visualization for doing maps, because if you recall, we're actually doing the arrivals from Changi. So R actually has a library called maps, and you can just get the map data from there. Other than the world map, I think it also has like US, States, and Southeast Asia, maybe some other regions as well. I can't recall. You can go to help and look for it. So first, when you load the data, you should look at the structure. So you can see we have longitude, latitude, region looks like country. Yeah, then you can look at the first 3 rows as well if you want. Okay. Yeah. So actually, in order to do the country map later, I need to do some data preparation. Data preparation. So remember the count by country which I did earlier? So we have to assign it to the variable. We have to assign it. We are going to use that chart. We are going to use that summarization in order to draw the world map. So because I'm familiar with the world map data, which basically means the first time I ran this code, it didn't look right. I convert the United Kingdom to be UK because actually that's what it is in the maps data. So that when I do the join later by country and region, it joins correctly. So now it looks like this. So you can see the value is actually taken from my count country table. Okay, so we have the Ggplot grammar again. So you use it for maps too. So we do the Ggplot on the dataset. You set the aesthetics. You actually, this time you put in a geom polygon because that's what they use for maps. And then the scale, actually it sets the scale color. So after that, it looks like this. Yeah. So like you can see, the darker color has less arrivals, and then the lighter color has more arrivals. So it looks like probably Indonesia. Okay. So another thing about creating easily reproducible analytics is that you should use user-defined functions to improve readability. So how do you determine what is a good candidate for user-defined functions? So if you look at this code here, just by looking at it, you can't really tell what I'm using it for, right? So I would use this code. I would change this code into a user-defined function because to improve readability, the ease of maintenance, and maybe because I would need to get like the past 12 months at another time. So just to recall, so once I run this code, then I get the month lower bound. So this is like 12 months ago, right? The current data with the most recent 12 months of data. Okay, so this is how I would create the user-defined function. So I call it something which makes sense. I create a function. The parameter is, I don't need to go and set like that is an in or char or something. I just need to call it a name. And then basically I copied and pasted everything from my previous slide into the middle. And then I did some garbage collection at the end. And then what I return is the month lower bound, because that's the actual thing which is useful for me later on. So if you remember, like many slides ago, after that, I did a filtering based on this month lower bound. So if I saw the function get 12 months ago date, as opposed to like just seeing these like 3 lines of code, it makes more sense. So we just validate that like what I did previously and this time around, the text is the same. What comes out is the same. So like what I said before, generally when you're creating user-defined functions, the main reason you do it is because you want it to be easily readable, so that the next person who is trying to reproduce your code, who is trying to understand what you're doing, can do it easily. It's easy to maintain, so if you need to use it again, then it's easy for you. Ideally, you should store these functions in a central folder, and you can call all the common functions using this command. RStudio and version control. I think there was actually a lightning talk which went on at 2 o'clock talking about Git. I'm not going to talk about the details of Git, but basically it is compatible with Git and SVN. And you can create a project from version control, and you can do commit, reverse changes, stuff like that. Generally, I tell people who come in, try not to use file naming conventions to do version control. You know how people do version 0.1, 0.2, 0.3, and then whose 0.1 are we using again? Whose 1.1 are we using again? Well, generally Git and SVN helps with this kind of issue. So for those of you who are not familiar with Git and SVN, who is not familiar with Git, so this is what it looks like. So I can see the differences which I've made, right? Yeah, so this is the different changes which I made to my slides, right? Because I didn't commit it. And then you can commit it and do the general stuff which you want to do with Git and SVN. So let's say you already have something on a central server. Then you can also create it from the central repository. So let's say you saved it on a shared drive somewhere with your team, and it's already in Git. Then you can actually just pull it in. And then as you update it, you can just update it, commit it to Git and things like that. Yeah, Git is actually I actually find Git very useful. Yeah. I still have time, so I actually have some bonus slides. So one popular thing people like to see is social network analytics. Social network analysis. So this is just some code on how the libraries which you use to do a social network analysis. And I've actually lifted it from, I've actually amended it from this source website below. So the first one, I load the libraries. I create a data frame. So you can see the source, the target, the value. And then actually this part, what it's doing is that it takes all of the data from all the text from here, all the text from here, then it gets the unique values. So basically it knows how many nodes to get. So I call the network, graph from data frame, then I plot the network, and it looks like that. So yeah, so this is useful if, let's say, you want to see how people are connected. And the last few talks I've been at, people seem to find it impressive. So I thought it's good to share. Another thing which is actually useful to see transaction flow is a Sankey diagram. So what's a Sankey diagram? You'll find out in the next slide. So what I did is I used the network information from here. And then I set the Sankey diagram information, like the links and the node, the source, the target. And then I created a Sankey diagram. So why is this actually important? Because let's say if you want to see how stuff is flowing in and out within your network, this is something very useful. And let's say you want to see my transactions are going from here to here to here to here, and then sometimes it actually flows back. It's also good to know. It's a good way to visualize. Whereas you can't really do that kind of visualization. You can do the visualization here, but I think it's always good to have another type of visual. And then of course you can move it around. So that's something which looks nice. I still have a few minutes. So my last bonus slide is about word clouds. So these are the libraries you use for word clouds. And for those of you who are not from Singapore, it was actually our National Day earlier on this month. So there was a National Day rally and the Prime Minister gave a speech. So I downloaded the text from the National Day rally. I read it into the system. Then there's some like standard stuff to do, like you convert everything to lowercase, remove numbers, remove stop words. If you want, you can remove other words too. You remove punctuations, you strip the white space. And then actually it's very easy to create a word cloud. And it's very nice, it's very visual, and management seems to like it. So yeah, so as you can see, the most important word this year in the National Day Rally was will and Singapore. We used that word the most. And that is actually the end of my slides. Thank you very much. Any questions? Yes. Which one? This one? Visualization or before? This one? Summarize the data. Here? How do I normalize? How do I normalize this data? Actually, I didn't normalize it. I didn't really do anything to it, other than like changing the country name. Like what is happening here is that it's grouping the data by country. Then after that, it sums the value together. So if I wanted to, let's say if I wanted to group it by region, then I could have grouped it by region. I just changed the country to region, and then you would see all the regions below. I'm not sure if I'm answering your question. Yeah, yeah. So I'm probably answering the wrong question. This part? No. Sorry.
Normalization is required when you are having some fields missing, right? So maybe in
Yeah.
this case the data has everything. No,
yeah.
normalization is required when data is very much. It's not when missing data. Missing treatment is different.
Okay. So
Data is missing, that's when the transformation is.
Okay, so normalization means different things to different people. So for some people, let's say changing all countries to be the same thing, that's normalization because I'm normalizing the data, so everybody is the same. In my work, we convert some of the transactions to look like a normal curve. So from a log, it to become normal. That's also one type of normalization. So it means different things to different people. Probably you can look for me separately, so I can probably understand you better. Yeah. Are there any other questions? Yes.
So for someone who's also like probably has an introductory view into Python, if I get started with R, what are some of the resources that you would suggest?
Actually, the RStudio website and the R website is very good, and they actually have like there are some. I think there are RStudio cheat sheets. So these are the cheat sheets actually produced by RStudio are very good. So I would recommend you download the cheat sheets. Yeah. So these are the things which I provided to the intern at my in my team as well. Yeah. Yes. Yeah. Yeah.
So I'm just curious if R has some other features such as predictive analytics as well, where you can gather, produce
there are predictive analytics libraries which you can use. Python also has libraries which you can use. Actually, I haven't actually used them, but like they are there and they are well documented. So you could use it to use time series prediction as well. In terms of R Markdown, one little known fact is that it can actually call other languages as well. So if I didn't want to call the language in R, I could actually change it to like SQL or Python. Like I can change it here and then I can run like a select star SQL and then I can assign it to an R variable. Or I can do Python visualization in R Markdown as well. So for my work, we have some stuff which is in SQL databases. So sometimes I will do that. I will just like pull it out from SQL and then I'll give a visualization. So I don't usually do it in Python because like generally most of the stuff you can do in Python for data analytics you can do in R as well. Yeah. Well, most of my data sets come from my users because I work in compliance, so it's usually pretty sensitive. So like remittances, transactions. So they come from within the company. They usually come from within the company. So like they usually come from within the company. I don't usually use external data sources. We have millions of transactions. I work for UOB. So we deal with millions of transactions, and that's more than enough data for me to do analytics on. In terms of libraries, like the libraries I use the most in terms of analytics would be Diplia, Ggplot. For statistics, then we also use like for normalization, use things like box clocks, inverse hyperbolic sines, statistics, stuff like that. Then you can also do clustering. I can't remember the libraries offline. Usually if I Google for it, I'll just use what comes up on Google. Yeah. But generally I actually think that R and Python, they are not like stuff which they have stuff which overlap. So if you're already comfortable in Python, then maybe you should, then I don't have a problem with continuing to use Python. So just that for me, my familiarization is with R. And I think that for new users coming into data analytics, it's actually much easier because I install R, I install RStudio, and then basically I upload the CSV and I install some libraries and I'm good to go. Yeah, so whereas like for Python, there's a lot of choices about what is the IDE to use and what is the notebook to use, and it can get confusing for new users. So I think there's a lot of like chatter online about is R better for data science or is Python better for data science. I think it just depends on like what you are more comfortable with and what you're using it for. So there's no real like best answer. You have to see what your problem is and who you're working with. Because like if the person you're working with doesn't know Python, then only knows R, then it's probably best that you use R. Yeah. Or if they only know Python, it's probably best you use Python. Yeah. That's my 2 cents. Any other questions? I think. Yeah, yeah, it is. It is. Yeah. This, I can call Python code from here. I can call R code from here. I can call SQL code from here. I have integrated with things like Elasticsearch, which is on Anaconda. So yes, it is integratable. So yeah. I'm sure you could, but like most of the time the data I get is not real time. Yeah.
Not that you can use integrate
You could call a web API. If it's available via a web API, you can just call the API. Yeah. So I did that like for I think for a school project using Twitter. So like they just call the Twitter API, then they get the latest tweets with a certain type of with a certain which have certain tags in it. So it's definitely possible. Yeah. And
Can you get that as the last question?
yes, so if you have any other questions, please look for me directly.
Okay. So I guess that's it. Let's give our speaker. Everyone question, just a question. So after this, we have a tea break before the remaining sessions begin. So thank you all very much for attending.
Thank you.
Can we have a quote?
With this?
With that. Yes, with that.
Oh, maybe let me put up my slide.
Yeah.
Yeah. Oh, why don't all of us take a photo together? Or maybe after. Okay.
One more. I got there. 1, 2, 3. I think for you later I send you. Ready? 1, 2, 3. Okay.
Thank you. Do you want to take a photo too?
Yes.
Yeah. Come. Why don't you take a photo too?
You're in video.
1, 2, 3. One more. 1, 2, 3.
Thank you so much for your presentation today.
Oh,
It's very helpful.
okay. You're welcome. Do you use like R or Python? Or
I'm quite beginner to R.
Oh,
That's
okay.
why like I find your presentation is very helpful because
Okay.
it's a lot of things for me like because when I'm beginner
Mm.
it's easier to follow.
Oh, okay. That's great. What industry are you in?
I'm in banking as well.
Oh, you're in banking as
Yeah,
well.
so
Okay.
yeah.
Which bank are you with?
Deutsche Bank.
Oh, Deutsche Bank.
Yeah.
Okay. Yeah.
I just want to ask like how can we get like the copy of like your slides? Is it
There will. My slides will be shared with the attendees, right?